Every connection you make begins with a network, invisible yet essential to everything you do.
Today, we'll explore every type of network: LAN, WAN, VPN, and beyond.
We'll start small to ignore the local area network, or LAN, the foundation inside homes, offices, and labs.
A LAN connects computers, printers, and storage devices through cables or wireless access points.
At the heart of every LAN is a switch or router, directing traffic with precise timing.
Beyond the local, we step into global scale, the Wide Area Network, or WAN.
WANs link multiple LANs together, crossing cities, nations, and oceans to form the Internet's backbone. These connections travel through undersea fibers, glass strands thinner than a hair, carrying light at incredible speed.
Within each region, thousands of smaller networks interconnect through data centers and wireless backbones.
When distance or privacy becomes critical, we create a tunnel down, a virtual private network, or VPN.
A VPN wraps your data in encryption, converting readable information into secure, coded signals.
Those signals travel through public networks, but remain unreadable secured by encryption keys shared only at each end.
But networks don't end their way. From local to global, they exist in layers, each with its own logic and rules.
At the core of the Internet's design is the OSI model, 7 layers that define how data moves and transforms. Each layer handles a specific role, from physical cables to data packets, and from sessions to applications. Routers read destination addresses and send data along the most efficient route, constantly adjusting paths.
Switches direct traffic within networks. Routers link those networks together, forming an intelligent web of paths.
At the highest levels, networks link entire organizations through intranets, extranets, and the cloud itself.
Cloud networks abstract the physical cloud, connecting virtual servers, storage, and apps through software-defined links.
These systems scale dynamically, expanding or shrinking as traffic demands change. But every network, local or global, needs one critical layer: security.
Encrypting protocols like HTTPS guard against intrusion and haven.
Security isn't a single wall. It's a layered system, built to adapt to constant new threats.
Together, these systems form the invisible architecture of connection, the language of the modern world.
Every packet, every signal, and every line of code, all part of one vast, evolving network of trust. Beneath every network connection lies a universal language, the Internet Protocol, or IP. IP assigns every device a unique address, a digital coordinate that identifies where data should go. Routers use those IP addresses to forward packets from one network to another, choosing the most efficient path in real time. Every packet travels alone, finding its path independently. Some arrive first, others later, all reassembled perfectly at the destination. To make those independent packets reliable, another layer steps in, the Transmission Control Protocol, or TCP.
TCP ensures that packets arrive correctly, in the right order, and that any missing pieces are resent automatically.
Together, TCP and IP form the backbone of the Internet. Reliable, flexible, and universal.
Yet for humans, numbers aren't ideal. So another system translates, turning names into those numerical addresses.
The Domain Name System, or DNS, is the Internet's directory route, converting names like apple.com into numerical IPs.
DNS servers work in hierarchy, from root to top level, and finally to the local resolver that finds the address you need. That translation happens invisibly, in milliseconds, before your browser even begins to connect.
And once that address is found, another protocol takes over, delivering the actual content you requested. The Hypertext Transfer Protocol HTTP protocol is how web browsers and servers communicate across that network. Every page you open, every image you view, every click you make fluff, all become part of billions of HTTP requests every second.
Modern web traffic uses HTTPS, the secure version, wrapping HTTP inside layers of encryption for safety.
Encryption relies on digital certificates, confirming identity and building a chain of trust across servers and clients.
Behind all this activity is timing, the silent choreography of milliseconds that make networks feel instant. When packets collide or fail, the system resends automatically, using algorithms that optimize delivery over time. These protocols keep every connection reliable, so your messages, videos, and updates arrive exactly as intended.
As devices multiply, networks reach toward the sky. The cloud becomes our new ground. Cloud networks link distant servers, balancing load and latency across continents.
Edge computing brings data processing closer to the source, speed born at the boundary. Lower latency means near-instant feedback, Kavin, the invisible pulse that defines modern life. Next, the network goes mobile, a pigday, millions of towers forming a living mesh of data. 5G expands frequency and density, allowing billions of devices to coexist seamlessly. Millimeter waves travel short distances but carry immense bandwidth, speed at the cost of range. IoT extends the network to every object, sensors, machines, and homes, sharing silent data streams.
Network slicing divides one infrastructure into many virtual lanes, each tuned for a purpose.
Billions of connections now orbit the planet, a living network of networks.
Beneath the oceans, fiber cables carry almost all international data, threads of light under pressure. Above, constellations of satellites extend reach where cables cannot through, light in motion. Redundant routing keeps data flowing even when paths fail. Resilience by design.
All these layers merge into the internet's backbone, vast routers linking continents.
The network's reach is planetary, but its story is deeply human, shaped by connection itself. With connection comes exposure. Every open port, every packet needs protection. Encryption transforms readable data into the cipher cell, invisible to anyone without the key. Symmetric encryption uses one key to lock and unlock. Asymmetric uses two, public and private.
When you see HTTPS, it means your data travels through an encrypted tunnel, private by design.
But for full privacy across public space, we tunnel deeper, into the virtual private network.
A VPN hides your traffic by encrypting it and routing it through secure remote servers.
It hides your real IP, giving you a new identity, a mask in the digital crowd. Corporations use VPNs to link remote offices, private highways through public roads.
Firewalls act as gatekeepers, filtering good traffic, blocking harmful packets. Intrusion detection systems monitor every flow, spotting unusual motion before damage spreads. Layer upon layer, we build defense, encryption, tunneling, detection, and trust. Zero Trust assumes nothing today. Every connection verified, every session earned. Security isn't one wall cloud. It's a tower of layers, each defending the next. Every safeguard adds strength, but perfection is illusion. Security is constant motion. What protects us isn't the code alone, it's the vigilance,
written in every connection. As technology evolves, so do the networks. Faster, smaller, more intelligent than ever before.
5G compresses latency to milliseconds, linking billions of sensors into seamless motion.
Network slicing creates virtual lanes inside a single 5G highway, one for every purpose.
Edge computing brings the cloud closer, shrinking the distance between data and decision.
IoT networks form living meshes, devices speaking to one another in silent synchronization.
From rooms to cities, from Earth to orbit Priume, networks scale without boundaries. Satellite constellations extend the internet beyond land, ramming, connecting even the silent oceans.
Beneath the waves, fiber optic arteries carry nearly all our digital heartbeat.
Massive data centers route petabytes every second, the unseen backbone of digital life.
6G envisions networks that think, optimizing themselves through machine learning in real time.
Quantum networks promise unbreakable security, photons entangled across impossible distances.
Yet every new connection demands balance, between access, privacy, and trust.
We've built a web of light, invisible, vast, alive, carrying our collective voice.
From cables to clouds.
This is how the world connects. One signal, one pulse, one network at a time.